Alright, welcome back. So the plan for today is to try and explore the min-max algorithm, and I'm gonna do it for a simple use case. Like last time we did it for tic-tac-toe, but it wasn't really that in-depth because it was mainly focused on dynamic linking. But today let's do it for connect for, which is more complex but still quite simple. So quite a simple game. And I implemented the connect for offline, but it's really similar to tic-tac-toe. So it's fine that you missed it. It's going to be basically you choosing a column, and it's going to fill in that column, right, with your choice. And for the player, right now we are doing random, but the goal is to have it like a smarter AI that can actually beat us, because I guess here I was lucky. But the A is still random. So yeah, that's the goal for today, is to have an algorithm that can maybe defeat us all the time, or at least an algorithm that can defeat the random player every time. So yeah, and we can have like a short recap of what I did. I mean, it's not really a recap, it's like a showcase, but we have display function. That's the function that shows the board like this. Then we have check for win or draw, which is going to return one of these values, or 0 if it's nothing. But if player 1 wins, if player 2 wins, or if we have a draw. Then we have a function that's checking if a column is full, and then we have a function for update board. And the reason why I made them into a connect4.h is because I want them to be available for the AI players, right? I want to make it easier to be able to use some of these functions for the AI players. Because for tic-tac-toe last time we just implemented everything in main, and then of course we had the move function outside of main, and we had something like load move function, which is using dl open and dl sim to get the functions. But because we had the rest of the code in main.c, we weren't able to access that code really easily in the AI, right? So if we check, for instance, random, you'll see that we have this connect for function, but we also have a reference to connect4.h. And if we check makefile, for instance, for random, we compile random.c, and then when we compile the shared object, we merge together, I guess you could say, random.o and connect4.o. So we give it access to those functions from connect4.h, which is kind of neat, right? And then in main, we are able to just call these functions, right? Like player 1, player 2, move player 1, move player 2. And yeah, to be able to clear the screen and show that updated version every time, I'm using this stty cooked. Don't ask me, it's just something I figured out, I guess, when I did the Tetris game for Arduino like 1 year ago or something. But yeah, and then we have the clear screen, like it's a code which clears the screen, and then you just redraw everything. So yeah, anyway, with that out of the way, we should be able to implement different logic for connect4 move, right, in a different file. So let's try to do that. Right, so let's call this one minmax.c, and let's, I guess, just copy paste random into it, and let's just delete everything from there, and let's try to think about our minmax function. So I guess how minmax is going to work is we are going to give it the board, and the player that we want to maximize, and we want to go recursively, try every move, every possible move. Initially we'll start with something that's unoptimized. We won't care that, you know, some moves don't make sense. We'll just go as deep as possible until the end of the game, and we'll try to get the best score for our player and the worst score for the opponent. So that's the, you know, that's min-max in a nutshell. And for the return type, would be nice to return the score and the best move, but I guess, you know, in C you cannot have tuples unless you have a data structure for it. Honestly, just thinking, yeah, it doesn't really matter. We can have a structure. Let's have type def structure connect, or I guess move score or whatever, and we'll have the move, which is an integer, and the score, which is another integer. So move score. So our minmax is going to return move score, and it's going to be called minmax. All right. For the board, we want to be able to change it. So we want a reference here, because when we make a move, we want to make it persistent and then swap the players and, you know, try the other player with a move. So we have to be able to change it, but, you know, we don't want to change it here. We want to undo all the changes pretty much. And then maybe another field would be, if we are trying to maximize the player, I'm just gonna say maxing, like in looks maxing. Now we got connect for maxing before GTA 6, but that's fine. So we have the board that we are going to change, and we have the player, the current player, and whether or not we are trying to win with this player, with the current player that's here. Right. So I guess what we are going to do here, although I have no idea how we are going to pass this const board into there, but so the board is just 2D array. Okay, can I do something like return minmax and then reference to board player, and we are trying to max it, we are trying to win with this player, and then we just return the move. So it complains that it's incompatible pointer. Types passing. Well, I mean, then it means I don't need to let's have connect for board D. Let's call it copy, and let's assign board to it or something. It doesn't work. Okay, let's make it 0. Then we pass the reference, and then maybe we can mem copy. So mem copy takes in the destination, the source, and the size. So we can say, okay, we want to copy into copy from the address of board and size of connect board or whatever. And we need string.h. And it actually works. That's interesting. Anyway, I wasn't expecting that, but it's fine. So I guess the first thing we need to check, you know, when we are talking about recursive algorithm, we always need to check first for the base case because we don't want to have an infinite recursive loop. So, what's the base case in minmax? So the base case is when one of the players wins. That's the easiest way to put it, or when you get a draw, but that's that. So let's get this function, check for win or draw, which is available obviously, and we are going to have a char result, right? And we need to dereference the board here. Perfect. So if we have something that's not 0, which means that we have a win or a draw, we need to do something, and otherwise we need to do something else. Okay, so what happens if we get a draw? So if result is equal to connect for draw, well, we want to return score is equal to, can I maybe do this and move is equal to -1? It doesn't like that. So let's have I don't really like calling it result. Okay, let's have move score value, and let's assign this thing here, and then we can say return value, right? And then we have some big ifs to build, right? Let's call this thing if is the good case, or like in good case it means that the maximizing player has won. That's what we want, or at least what the AI wants. So when does the maximizing player win? Well, obviously if maxing is 1, that's the, how can we say, that's a requirement. So maybe we can say if we are maxing, and then we have some, maybe we have two cases. The first case is the result is equal to connect for player 1, and player is equal to x, or I have a define for it, it's called player 1 ch. So that's player 1 has won and we are player 1, and then we are also maximizing. Or the other case obviously is the same thing, but with player 2. So if we are player 2 and player 2 has 1, right? That's, maybe we can do something like that. Okay, so this is the good case, right? We are maximizing and our player has 1. Okay, perfect. So if we are on the good case, in Python would be really nice, we can use infinity, but I don't think we have infinity in C. So let's just say minmax inf is gonna be some big number. Minmax inf, oh, I guess I'm just gonna say value.score is equal to minmax inf. Else is equal to minmax inf, but with a minus. And just to be annoying, I'm gonna do it with the ternary operator. So good minmax inf, otherwise minus. Right? So that's the idea. And the move is gonna be -1 because we don't really care about the move, right? I guess. Because, you know, if you go, let's say you choose a move, right? And that's not a winning move, there's nothing, that's just a move. But the next move you do is gonna be winning. So the move that we want to return is not the last move, obviously. You know that it doesn't make sense. We want to return the first move from the sequence. So that's why here it makes sense to return -1, because this is not the move that we want to play immediately. The move that we want to play immediately is the one that leads to the winning position. So yeah. Anyway, so if the result is 0, meaning that we don't have a win yet, maybe what we want to do is to iterate all the possible moves and just make a move. So here, if we don't have so here we just iterate all the columns, which is like, what if I play move 1, what if I play move 2, and so on, 7, right? That's the idea of this for loop. Then if one of those columns is empty, or I guess it's not full, then we can just play it. So that's the idea. Let's copy something else from main, which is this one. So in main, the difference you can see here is we choose one move and we play it. In minmax, we are going to go through all the moves or all the columns and play all of them. But we have to be careful. Here we update the board. Okay. Like maybe it makes sense to do something stupid like minmax can also be a copy, and then here we make copies for updating the board. And then, but I'm just thinking that we are going to make so many copies. But at the same time, I think that's the easiest way to do it though. So let's just do it like that actually. So instead of sharing a reference, and then, because what we need to do here, if you let's just write it and see, explain what I don't like about it. So here I would say I would need to do something like minmax and pass in the board and whatever the rest of the stuff, and then we need to say something like undo move on the board. That kind of sucks. So what if instead of passing a reference here, we just pass the same const board, right? Const board, and we just make a copy of the board here. And then we don't need to dereference this one, we don't need to dereference this one, and here we are going to make a copy of the board, right? We just copy it, and we say update board on the copy, right? And the move is I, obviously. So now the cool thing is we're going to make a change on the copy, so we don't care that it was changed, and the move was I. Perfect. So if that failed, let me just include this .h for a sec. So I'm gonna say ds panic, and maybe ds something like ds unreachable, something. Yeah, because this thing shouldn't happen. Like update board, think connect C. Update board would fail only if the move is invalid, or if the move is out of bounds, which I mean it's also invalid. But you know, we make sure here that it's not going to be out of bounds, and we also make sure here that the column is not full, so it's unreachable pretty much. But anyway, so we made a copy, we updated the board, and we need to call to minmax recursively. So let's say minmax, right? We need to pass in the board, which should be copy. Now it's interesting, player. We need to swap the player. Now here, yeah, sure, whatever. Well, actually, here I guess I made a small mistake. I don't think we need this X and 0. I think that the character is actually, yeah, it's gonna be like this. So then here this if statement becomes even easier. It's just result is equal to player. I don't know why the fuck I was complicating the things too much. Yeah, so it's maxing, and the winning player is the player, right? So that's the good case. Okay, whatever. So inside of main we have this swap player function, which, yeah, sure, could be part of connect 4, but I guess it doesn't matter. So I can call to swap player, and what should we do here? Just reverse maxing. Hopefully, just calling exclamation point on it, it's going to reverse it. Okay, so we need to get the result from this thing. So let's have something like move score value is going to be equal to the result, and at this point we need to check if the value is better or not than what we currently have, right? Something like that. So at this point, it might matter whether we are trying to maximize or we are trying to minimize, or I mean, you know, not trying to maximize. So if we are maxing, right, we want to find the score to be greater. So let's before we start the for loop, let's do something like move score best, and this one is going to be score is equal to 0, move is equal to -1. All right, and maybe if maxing, we are going to say best score is -infinity, right? Else best score is going to be minmax in, right? Because here it's like you know, if you ever did your own trying to find the maximum value in an array function, you know that usually you start with something like -infinity and you check for finding the maximum. So here, for instance, we can do something like if value.score is greater than best score, then we need to update the score and the move. And the move is going to be I, right? The move that we just made. And here you see we don't take the move from the result of minmax because it's irrelevant. We take the best move that leads to the best score, and the best move that leads to the best score is the move that we just made. So that's the idea. And you know, if the score is too low, then it is what it is. The player is cooked. And if we are not maxing, so on the other case, if value.score is lower, right? It has to be, yeah, it has to be lower than best score, because we are trying to minimize the score. Best score is equal to value.score, and best move is going to be I. Right, and at the end we just return best. And I think that should be all for basic minmax, you know, without any using depth and anything. So let's try to use this algorithm for us. So let's add it to the make file. So I'm going to compile minmax.o from minmax.c, right? Just like that. Sure, if you know, if ds.h changes, then we also need to compile it, and that's in src. But whatever, let's not worry about that. And then we need to compile libminmax from minmax.o and connect4.o. So if I, oh, and I need to add it here as well. Libminmax, and if I run make, it should create minmax and libmin. The only problem that I would see with this implementation of minmax is, oh, so somehow it wasn't unreachable, which is pretty funny. Let's try to display the board, and then maybe just break. I need to run make again. Oh shit. But why did it show it this broken? Maybe this, it's 42, which is fine because it's 6 times 7, right? Which makes sense. Right, yeah, it's 6 times 7, 42. So it should have the same values. But why was it invalid? Was it this one? Let's just printf this thing. Wait, why is it printing all that crap though? So it got here somehow. Is column full? The fuck? Board column and I. So it's like 0 and something. Strange. Oh, I forgot to say that. Anyway, let's have something like int j0, j is less than connect for height. I just want to print f %d maybe from copy, and it's going to be shit. I think it's width first, height second, so it's I J. So it's filled up with a bunch of trash. That's pretty interesting. But I guess even the... Well, I guess let's do mem set copy, and mem set is the thing, the byte, and the size t. So let's do 0 and size of connect for board t. Let's try to do mem set. Maybe it's equal to 0 is not enough. Doesn't work. Well, I guess the other option is to not use memcopy, is to just have something like for int j goes for height, and then for int k is less than connect for width, k++, and then we do just copy at kj. Maybe it's because this is like list of pointers, and if you use memcopy you need to memcopy each eighth pointer. Yeah, I guess, you know, memcopy didn't make sense because it's not a continuous block. So it looks like now it's still waiting, I would assume, right? Because it's not done, right? And that's because we are trying to simulate the entire game. That's pretty bad. I was trying to stop it, but that would be the thing I'm thinking happens here, right? So it's going to try to simulate the entire game and then just make a move, which is kind of bad because we want the AI to be faster, but I cannot stop it literally. Can I have grep main? So this thing, maybe we can just kill it. Right. So again, the problem here is that it's going to take a lot of time if we don't add a depth to our min max. And you know, I was hoping it's not gonna be this bad, just so I can show that okay, there is a difference. It's like 10 seconds without depth, and with depth is gonna be 0.01 seconds. But looks like it's not even finishing without depth. And the idea of depth is to just say something like, okay, look ahead, I don't know, 10 moves or something like that. Let's do 5 moves. Okay, so now the base case is not just that the result is different than 0, it's also that or depth is equal to 0. All right, but I guess let's do it in a different if. So if the result is something like a draw or a win for some player, we end it, and then if depth is 0, then we have to do something different, right? And here when we go again, we just say depth -1. Okay. Usually I think you want a depth, like the best depth to have is something that ends on your opponent's turn, but not sure. Anyway, so what should we do if we get to a depth of 0, right? That's a good point. We need some kind of evaluation function to, evaluate our current position. And I guess for Connect 4, or I guess even in chess, but I mean for chess it's different because you also have the values of each piece, but you might know that certain squares are more important than others, and that's kind of the same in Connect 4. Like if you, for instance, let's say we go back to playing against random. So in here, like this square, obviously it's less valuable than the one in the middle, because the one in the middle can have a lot more wins. I guess you can win like this, you can win like this, you can have all sorts of winning possibilities from a central square compared to this one. So I would say that an idea of how we can have an evaluation function for Connect 4 is to just have a weights matrix and put some values for each square, and then based on that we can say, okay, you have a piece here, you have a piece here, and you have a piece here. Let's say somehow you managed to do that. So we can even play some more just to think about it. So let's say it looks like this, the current game. So we have a square occupied here. These values a lot more than other squares, but it's also like a win in one, so it's a threat for the opponent. Probably if the opponent has a depth of 1, they'll see that, okay, if the enemy plays here, they're gonna be winning, so I have to play there. But other than that, it's like, okay, this square's values a lot more than other squares, so I'm better in this position somehow, right? Like I have better squares occupied. So that's my idea here. And I mean, it's not really my idea, it's I guess how you do min-max for this thing. So let's try to create a function called eval maybe, and it's going to take in a board, and I guess let's think. I'm thinking, should it also take the player and the maxing? It's like I want the score to be yeah, I guess it needs player and maxing maybe. I don't know. Let's just keep it for now. So as I said, we need this kind of copy, which is gonna be the weights. So I'm gonna call it weights. And obviously we need to initialize it somehow. Okay, we need to initialize it, and then we need scores for each player. So int score 1 is going to be 0, and then we are going to do something like weights times board k. Well, it's not really actually, yeah, it is, right? It's board kj equals to connect for player 1, right? And that's gonna be score 1, and it's going to increase with this amount. Yeah, maybe I don't need that. Anyway, so that's gonna be score 1, and score 2 is going to be similar. I was just thinking I can get score 2 also in here. I'm just gonna say here player 2. So this is basically like dot product, right? It's the weight, which we need to figure out. Maybe, I don't know, is going to be something like this, right? So it's 6, it has to be 6 of them, and then 7 like this. So it's 4, 5, 6, 7. Wait, what? Wait, it's 7 total? Am I 1, 2, 3, 4, 5, 6, 7? Oh, it's fuck. So it's the width. So we have the height second. I guess it's transposed, which kind of sucks, but it is what it is. So this is 4. Well, I guess it's transposed, which kind of sucks, but it is what it is. Alright, so it's like rotated 90 degrees. So this is a column, actually, which is kind of funny, but it is what it is again. Yeah, whatever. We'll see how we put the scores, but for now let's just say it's all zeros, whatever. Maybe it could be all ones, as a matter of fact, but let's make them all ones. Why not? So here we get the score for each player, and maybe the score is going to be from the first player's perspective, so let's not need these things here. So maybe I'm just gonna do return score 1 minus score 2, and that's gonna be the evaluation, right? So at this point here, I guess that if we are, so it's player 1 minus player 2. I'm just thinking what should we return here, because it's gonna be the same thing with return value, but we need to figure out the score. So let's say diff is eval of the board. Okay, so it's player 1 minus player 2. So if we are maxing and if we are player 1, then it's fine, but if we are player 2, Then it's a bunch of ifs though. It's annoying. I'm just thinking that maybe it's gonna be as simple as this one. So yeah. Because like if we are maxing and we are player 1, then that's what we should return. If we are player 2, then I think we need to multiply it with -1. And then if we are minimizing and we are player 1, what should we do about that? Shit. Damn, it's kind of annoying. I cannot figure it out. Okay, let's think about it. So let's say we use a depth of 0. Let's say that we just want to see how good of a position we have. Let's say that we just want to use eval just like that, like a function. I mean, you would just call to eval, right? So I don't think it matters if you are maximizing or not. You are just getting the score. But I think it matters because if you are player 1 and you get the score, it's like, for instance, it's like in chess where you have the score. If the score is like +2 and you are white, you are winning. I mean, you are the one winning. But if you are black, you are the one losing. And if the score is negative, then black is winning. So should be the same here. If the score is negative, player 2 is winning. So if we are player 2, then we should multiply it with -1. And I think that's the only thing we need to do. But then, not really. Because minmax, so if we are player 1 and the score is positive, we are winning. If we are player 1 and the score is negative, we are losing. And then if we are player 2 and the score is negative, we are actually winning. So yeah, I think we need to multiply it with -1 if we are player 2. Maybe I could add in here the player perspective in eval, like from whose player we are looking, whose player perspective, right? Like at least that, maybe it can help. So here we can have the chart player, and here is gonna be like player connect for player 1. We do that, otherwise we do score 2 minus score 1. So it's like if you look at the score from first player's perspective, you have to do score 1 minus score 2, otherwise you do score 2 minus score 1. Okay, and here we can just say player. So we are looking from this player's perspective. But now it's interesting. If we are maximizing, I don't think it matters. So I think it's only value.score that we need to pass in here. So let's rerun make. And let's try again. Interesting. But why did it only move here? That's weird. Interesting. Because it, like, how can it even make an invalid move? That's weird. How can it even make an invalid move? Because we check that we check that the move is that the column is not full. Let's say just for the memes that, I don't know, this one is gonna be 5. Let's see if he's gonna move there instantly. Oh, did I forget? No, I did make. No, it's still something is broken. Printf %d. Let's see score 1 and score 2. Oh, 3 minus 3. I mean, it makes sense because it's 3 moves ahead for each player, basically. What if we make this thing 2, for instance? Is it gonna... See, at least it's 3 minus 4 now. At least it's 3 minus 4, which is weird because why does the second player have a better score? Interesting. Okay, the fuck? Well, I guess this was, yeah, that was the, I'm dumb. Sorry, so this should be 4 minus 3 now, yeah, okay. So it actually found that it should move here, but why did it move on the first column? Like it looked at a good evaluation, right? But why did it move so dumb? So that's the best score. Move is -1. Then we have a for loop with I. Then we check that the board is not full, that column. It's good. We make a copy of the board. We update the board with that player. And we call to minmax with the other player. Right. Printf %d. Let's see what I do we have here. Make So it goes through all of them. Wait, what? Jesus. Okay, I don't get it. I mean, it moves randomly though. But why did it lose at some point? See now, it's actually... Wait, how is it? How is the seventh column full? I'm doing something stupid. Wait, what? I never tried column 7? Okay, what? Oh, fuck, here it should be next. Okay, so... Oh. That's that's pretty funny. Okay. So I gave it something stupid and it literally just died. Okay, let's try again. Let's try again. So 1, 6. If I give it 5, is it? Huh. Interesting. Let's see if it's gonna win. Didn't win. Although that was like pretty easy to spot. Invalid move. Maybe I also want to see what's the invalid move. But probably it was just -1. Invalid move for player. And let's put maybe in parentheses the move itself. Maybe it somehow got -1. Although again, I don't know how it can get -1. So at least if I am the player, it's gonna tell me that, you cannot play there, but... So here it's gonna say invalid move -1. What didn't the AI like about this? Maybe it's like, no, but it's a win, like it can win here. Like why didn't it try to win? Right? That's strange. Maybe if it's a win in 1, it's failing to put a move. I was thinking that, oh, it's so that if it puts here something, then it loses, but it can move literally anywhere. So, okay, so when does it return -1 as a move? Can happen here, for instance, if it's a win or a draw. So if the game is already over, but I mean the game is not already over, right? Yeah, it's not. So that cannot happen. I would assume that we don't get -1 from here. A depth of 0 again. We have a depth of 5, so it cannot happen to get a move of -1 directly from here. Then the other option is that we have here a min-max minus infinity, and the best score is infinity if we are not maxing. So the only option is this remains -1, but that's somehow weird. So because there are rows that are not full, obviously, or columns, I mean, then it should be able to update, and it should be able to get some different value here. And value score is better than best score, which, I mean, come on, it's minus infinity, it has to be better. Well, should I say maybe better or equal? I mean, it knows how to avoid losing, but why doesn't it win? It's unfortunate. No, it it was like, nah, I can, I don't know. Why didn't try to win directly? Hmm. Yeah, like, why didn't it try to win? So if maxing and result is equal to player, because it was like it's a win in one move, right? It's a win in one. I'm curious. Let's print here, print f the player, %d player. It should be, I'm thinking about it, player 2, right? Oh, so if I press Control D, it gets yeah, okay. You know, maybe the player needs to be improved. The player plugin. So it knows that it's like player 2, right? And here I'm pretty sure it's gonna be player 2 winning, right? Player 2 is gonna be like, okay, I'm winning, and the result is good, so why doesn't it return inf, like infinity? I guess what happens is that it sees that it can win in multiple variations, maybe. Printf. Let's see if we get any, if we get good anywhere. Oh my god. I need to fix that somehow. Or at least I need to just press one key. Okay, so was it not even a single one with good? What the fuck? I'm gonna force him to play there. But not even once was good one. Or maybe was it here? No. Yeah, there was never a win. What the fuck? Let's print all of them. Percentage D, percentage D. Obviously, it cannot be a win already. So it knows that player 2 would win. It also saw player 1 winning. But yeah, somehow it seems a bit broken here. I don't know why. Yeah, I mean, maybe, I don't know, maybe I want to have something different here. Maybe like also have a chart turn, like whose player is it, and then the player that's playing the game. So here we get chart turn, and then we have something like this actually. So if the player that's playing is in a winning position, then we are good. Right, maybe that's the plan actually. But it's a bit stupid because we don't need that. It's like it's because here we pass the player and we also pass one for maxing, right? That's what we need to keep in mind. So if here if the position is winning, or at least what's my idea here is that this, when maxing is 1, player is gonna be the AI. So when we check here if it's a win, maxing should be 1 if the player is the playing player, or like the AI, right? Because that's how we pass it here. Because here in this minmax, we swap the player and then we also swap maxing. So maxing and player should have the same values. Then why the fuck? Why the fuck? I guess it makes sense that you know, one can win on our turn, or it's weird. Wait, wait, wait. How can that happen though? I see. So let's say it's maxing is 0 and we have the other player, right? So the enemy, like the opponent, makes a move that results in a win for them. Maxing was 0. So now maxing became 1 and we are playing. So what that means is when we do check for win or draw, the opponent wins, maxing is 1, but the player is different. So that's not good, which makes sense. So then, again, do we really need an extra variable for the current, like for the AI player? Something like who am I? It's weird. I guess maybe instead of maxing, we can have like AI and you know, like let's call it, let's make it char and have here player. Okay, let's keep it like it's the maxing player. So for instance here, maybe we need to do something like this. So the good case is when the player is the maxing player and the player has won. So that's the good case, I think. Or I mean, it's the same thing as saying as maxing is equal to result. Yeah, maxing is equal to result, right? So the maxing player has won. Basically, that's the good case. Okay, then where do we use maxing again? Here. So if maxing is equal to player, then the best score is minus infinity. Otherwise, it's plus infinity. Then we have maxing here, and maxing should stay the same. Maxing player is always the same player. Here, if maxing is equal to player, then we check for score like that. Otherwise, it's oh my god. Okay, let's make and let's try. So there it blocked. Okay, and it goes ahead and wins. Okay, let's try to win actually. So it blocked 7. Let's try hard this guy. It's 6. It's maybe 3 again. 4. Oh, it somehow missed that 4 is winning. Really? But why did it miss that? So if it played 4 there, I don't think it was a win for me regardless. Yeah, no. So it's just trash. Okay. I mean, you know, there is something. But I think doing it like this might be better. So we have the player and the player that we want to win. Or it's like the current player and the player that we want to win, right? So if the result is that the winning player is winning, then we return plus infinity, otherwise minus infinity. Okay, like, yeah, it makes sense. Like, it's so that player 1 would win at some cases, but it also had good cases, right? That's interesting. It also had good cases but also bad cases. Okay, like that's maybe interesting. But what did it so was a win? I have no idea. What did it so as a win? What I would do honestly, just to be able to see better, because that's kind of cooked, is to just remove these calls. So for instance, first there was no like winning because it was not that deep, but now it can see some cases where it can lose or win. Right here it blocked it. I wonder why. So it probably was like minus infinity at some point, but it also had this case. Yeah, I really wonder if here it should be greater or equal or not. Oh shit, I cannot. That's fine, I cannot exit. That's so cooked. Okay, let's make sure that I just do return -1. Like, I just resign if I lose. Okay, let's try to remove those. Like, anyway, it should try, I guess, the first good move from the list. So now it won because it's always gonna move in the first column. Now it, I mean, yeah, it blocked me there. Now it won. Okay, so maybe just giving it the first possible move is better. Just move it here. Okay, so it doesn't crash it anymore. Okay, that's good. Oh, it cooked me. Okay, now it looks better, honestly. Much better than before. Okay. It also blocked that. I mean, it's kind of cooking. It's kind of cooking. Not gonna lie. Okay, I don't even see. Oh my god, it went there. Okay, that's good. So that's an improvement. Let's make it play against itself, lib minmax actually. So it got invalid move. So it's let's see, invalid move for player one. So X didn't want to play anymore. It was like, nah, fam, I'm not playing. But it could have played here. So it's 0 to 1, 0 to 1. But why didn't it play? Like literally that's fine. Huh, not sure. Lib random. I mean, it's just there's no chance for lib random. Let's do lib random first and lib minmax second. It's still gonna win every time. There's no chance. But I need to figure out why it gives up. So what's funny is that it's always gonna have the same result here, right? Because they both gonna start like this and fill the thing up. But why does it give up? Nice. So here it's so that it needs to move here, I guess. Otherwise it was a loss. But yeah, why it gave up? Let's see. So if I check here, print f percentage d, I want to see like, okay, so it looks at 5 and 6. Interesting. And here in printf, let's see let's not put, let's maybe put a space. And here I want to show percentage d value.score. I want to see like the move and the score. I don't know why it's -1. Ah shit, it's coming from the recursive call. So let me then percentage di here. So it's always negative score for my guy. And what's, for instance, the best score? Best score is also -1. What? And then why doesn't it have a move? like it should have a, it has like move 5 here for or here. But yeah, here it doesn't have a move. Maybe that's for the other player. So I guess it makes sense. If it's the maxing player, the best score is minus infinity. And if it's not the maximizing player, the best score is plus infinity. But yeah, that's the weird part. Let's just say, okay, if he's the maxing player, I want to see. So if he's the maxing player, obviously if you want to move to 6, then it's a loss instantly. But if you want to move at 5, it shouldn't be a loss instantly, right? Or am I dumb? It puts 0, x, 0. It's not a loss. But here you see it finds a move. Or I don't know. Maybe it's not. Best score, best move. Let's say maybe let me also do like something like depth is equal to 5 just to print it for the first depth. So for the first depth, it says that if it moves to 5 is minus infinity. It's like what? Value score. But how is it minus infinity if it moves here? Oh, because O is gonna move here and it's gonna be forced. Okay, I see. Interesting. So if it's gonna lose, it doesn't want to move there. Maybe this needs to be greater than or equal, and the other one is just. So that's when that one wins. Huh. I mean, I would say it's weird that player 2 wins. I thought that the first player has an advantage. Maybe not. Who knows? I want to see if it's oh. Okay, so it knows how to win. Okay, so I don't know what the problem was before, but should be okay with greater or equal. Okay, nice. So we have the AI. Interesting. What we have to do though is to figure out what numbers to put in this 2D array, like trying to evaluate the squares. Maybe something like these are worth 5 points. Maybe we have to do less than that, right? And it also sucks that I have it transposed, but it is what it is. Let's do 7 for the ones in the middle. I don't know. Probably there is something online on how to do it, but let's see. Lib random. So if I play min-max against random, interesting. It looks like it's just beating his ass. Yeah, how wasn't it able to? Hmm. It's still dumb as fuck. It was like it's dumb and it almost beat me. Hmm. I want to have. Oh, I got cooked. Jesus. Let me be the first player. I want to be the. Let's try to win now. Let's beat the AI. I mean, I should try something that I have no idea how to win at this game, but it should be something that gives you multiple lines, right? Maybe if I keep playing at 4. And now it's like maybe 3. Somehow I missed that. Interesting. I mean, even if he put piece there, I think I was gonna put one here, and then I had the win here because you cannot block both of these. So yeah, I mean it was lost anyways. So yeah, I guess the AI kind of works. I mean it's gonna beat random every time, so it's not even a question. And if it fights against itself, it's I mean it's always the same result, but that's because when I choose a move here, I just iterate it like that. We could try to randomize it and get a random move, but yeah, like get a list with all the moves and choose a random move from the list. But yeah, and I guess for the last thing, which is kind of like if you have like a move so bad that the opponent won't play, it's something called alpha beta pruning. But honestly, this is like the part which I'm not really sure about. I guess the initial value should be like a min max inf and min max inf, and then where we have the minmax function, we need to include these values. So alpha and beta. So when we compute here, we should pass alpha and beta. And here we should update also alpha and beta. So it's something like if alpha is, no, I guess it's value.score is greater or equal than alpha, we say alpha is equal to value.score, and it's kind of the same for beta, but the other way around. So if it's less than beta, because beta is going to be the minimum and alpha is going to be the maximum, right? And in here, I guess that if alpha is greater or equal than beta, then we can just break, right? Maybe it's something like that. I don't actually remember quite well, but let's see. Let's see if it makes like a difference. So we play against lib_random, and player 1 should win every time again. Oh, player 2 won. Whoops. Lib player. Let's see, why did it... lose against random? So it didn't help though. Damn, it's trying to win. Ooh, I got cooked. Anyway, yeah, I really wonder why it didn't work with... Okay, so I guess using equals makes it worse for some reason when computing the score. So what I'm actually gonna do to not get a -1 move here is, in case the move is -1, we are just going to use random. So let's go to random, and we can initialize it like this, and let's actually copy paste this function, random move, and we initialize the move with random move, right? So best that move is gonna be random move board, and this way we are not going to get -1. So now in case we play something that the AI doesn't like and it gets beaten because of that, it's not going to give up anymore. So here I think it should have played that, but it was a loss anyway, right? So I can play either 4 or 5 and I'm still winning, so that's why it gave up. Interesting. So let's try to give it more depth, maybe. So let's give it 11 depth. Now would be cool to have, maybe have a define, and so if not defined, minmax depth, define minmax depth 5, and if. And now we can use min-max depth. And maybe what's cool is that we can try to have different depths for AIs, but now it's gonna take longer for each move, right? Okay, I mean, it's still gonna move the same stuff in the beginning, so. But it looks more menacing, it looks like it's thinking more. But it still sucks. Oh shit, it's cooking me. Did it? Oh yeah, it cooked me. I mean, it could have cooked me even before, but yeah, okay. Probably the best way to play this thing is to play in the middle, I guess. I mean, I wanted to do something else, but it is what it is. Okay. Oh shit, it's cooking. Let's say like 6. I mean, it's it's trying so hard now. I'm gonna lose. I mean, it's oh, I mean, it made a mistake there. I guess I was gonna win like this or something, right? And didn't want to play here. Uh, but yeah, I don't know why it gave up. Like, I guess it could have played here as well. I mean, if I played here, he would have blocked me here. And I didn't have anything, but yeah, I mean, just gave me the win. Yeah, I mean, it's still pretty decent, I'd say. It's pretty tricky. Maybe if I give it more depth, but it's gonna be extremely slow, so yeah, I mean 130 lines. We should try to make it fight with ChatGPT. Let's put something like 7, like this, maybe like a circle. Wait, what was the depth? Still 11, okay. Oh. Sometimes it plays the movie instantly because, you know, it's like, oh, it's like a winning move, but not always. but at least it finds some of the moves that you know, could win instantly for me or for him, I guess. I don't know. Just, oh, if I manage to fill the entire board without losing. See, and here it gave up again. Maybe it saw that it's like 11 moves and it's gonna lose, so it gave up. That's pretty funny. So yeah, I think that's the case. It's like it looked 11 moves ahead, so that if it moves here, it's gonna fill up the entire board, and I'm gonna put it here. So that's why it gave up, I think. But yeah, I mean, it's still pretty cool that it's still decent, right? I mean, if it would be lower depth at this point, I think it would move here or something, and at some point it's gonna see that it's gonna lose here, so it's gonna give up again. So yeah, but I think it's a pretty cool result. So yeah, I guess we got the objective done. Hopefully it was interesting to see. I mean, it didn't work first try without depth. I wish it did, but yeah, it didn't really work without depth. We needed to build the eval function before, like really early on, but hopefully it makes sense how the eval function works. It's like giving you points based on where you have the circle or whatever the symbols, whatever they are in Connect 4. And yeah, at the end with alpha beta pruning, I mean, honestly, it's pretty tricky for me too, but from what I understand, it's about your opponent making a huge blunder, and it's like, I mean, the opponent won't make that mistake, so I'm not gonna look into it. Right? And if it makes the mistake, then it's a mistake anyways. So that's why it's not worth looking into those moves. So yeah. So yeah, I mean, I think pretty good result. And if you want to see more stuff like this, you know, don't forget to like, comment, do all the YouTube stuff, and we'll see you in the next one. So see you.